Okay, welcome to the Unit 5 review video. What I'd like to do is I would like to go through one of each type of problem. There may be some problems that I will just say we will go over in class, and also to look at the answer key. For instance, number 1 and 2, I want to go through that in class. What I would like to do is look at number 3. So if you would go down to number 3 in your packet, number 3. It says the rate of change is constant in each table. Find the rate of change. Explain what the rate of change means for the situation. The table shows the number of miles driven over time. So you see the jump between 4 hours, 6 hours, 8 hours, 10 hours, and the difference in miles. And what you can see from your answer key is that every time you go up 2 hours, so what you have is you have 2 hours. Every time you go up 2 hours, you actually travel 112 miles. So if you're looking for a rate of change, you're looking for that hours to be just over 1. So what you need to do is reduce this down. Simply divide 112 divided by 2, and you get 56 miles per 1 hour. So this is actually the answer. And the reason is, if you want an explanation, it's because for each hour that passes, if you drive 1 hour, 56 miles will be traveled. You'll travel 56 miles for every 1 hour. Okay, then if you look at number 5, find the slope of the line. Remember, we're looking at rise over run. And if you look at the point that's right here and the point that's right here, if you go down 2 and over 1, and what I mean by that is from the point at negative 2, comma 1, and then the point at negative 1, comma negative 1, you're actually going down 2 and over to the right 1. So an explanation like I put on the answer key, it says between any 2 points you must go down 2 and over to the right 1, which means that if I am writing rise over run, the down 2 tells you it's negative 2. The over to the right 1 tells you it's 1. And so to reduce this down, you have a negative 2. So we say m is equal to negative 2. Again, where m is equal to slope. Sorry, had to clear my throat. So number 7, we have 2 points, and you have to find the slope that passes through the pair of lines. Well, first of all, I wrote down my formula. I labeled my x1, y1, x2, y2. I need to go ahead and plug stuff in. So y2 is negative 3, y1 is 4, x2 is 7, x1 is 4. Then I have negative on top. Negative 3 minus 4 is negative 7. 7 minus 4 is 3. So my m is negative 7/3, or negative 7 over 3 is my final answer for that slope. Number 10 and 11 are super easy questions. We're going to go ahead and skip over those. We can just look at those in class and also on the answer key. Number 12 says, what are the slope and y-intercept of the given of the graph of the given equation? You simply look at the form, and is it in slope-intercept? Yes, it is. Y equals negative 8.5x minus 2.2. So this is the m. This is the b, where I begin. And so my m value is negative 8.5. My b value is obviously negative 2.2. So that's my slope and my y-intercept. Slope is m, y-intercept is b. Number 14 is kind of the opposite of number 12, where you're given information like m is equal to 4, b is equal to 1, and you've got to put it in the form y equals mx plus b. So y equals m is 4, then I put x plus b is 1, and you're done. That's slope-intercept form because y is all by itself. Okay, number 16, if you look at number 16, it says write the slope-intercept form of the equation for the line. You look at the graph, you find your m value, which is your slope, and it looks like you go down 3 and over 2 between any 2 points, which is negative 3 over 2, and also you cross the y-axis, which is the y-intercept, at, oops, sorry, I was going to write another b, at b is negative 1, and so you simply write down your y equals mx plus b, plug in your stuff, which is negative 3 over 2, x minus 1. Some of you would want to write a plus a negative 1, which is a good place to start, but you ultimately must get it down to minus. Number 19, you can do this 2 different ways. I'm going to show you my favorite way, just to get it in point slope form and then use slope-intercept form after that. So what we need to do, first of all, is realize that if I'm going to use point slope form, I need to write that down and know what I need to find. So point slope form is y minus y1 equals m times x minus x1. And I'm going to need an m, which is my slope, and an x1, y1, which is a point. Okay? Now, first of all, I do have an x1, y1. Let's pick that point right there. So, my x1, y1 is simply 3, 8. My m, however, I don't even come close to knowing. I have no idea what it is. However, I can know what m is by finding m using our formula we've used a lot of times. And so I hammer through this. y2 is -2. Those are my points. y1 is 8. x2 is 7. x1 is 3. So -2 minus 8 is -10. 7 minus 3 is 4. Reduced down is -5/2. So that's my m. So up here, I can get rid of the question mark and say that m is equal to -5/2. I have my information. That's awesome. So over here where I'm doing my work, I can plug all this information in. This is m. This is x1. This is y1. So over here I'm plugging all that stuff in. Y minus my y1, which is 8, equals my m, which I just found to be -5/2, times x minus my x1, which is 3. So now I just simply need to, well, first of all, that actually is cleaned up in point slope form, but now that's point slope. Now I need to get it in slope intercept form. So I want to get it down to slope intercept, which is y equals mx plus b. You want to get y by itself. Okay? So I need to do a couple steps. The first step is to distribute, and I get y minus 8 equals -5/2 times x is -5/2 x, and -5/2 times -3 is +7.5, or I'm going to use +7.5. And then my last step is simply to add 8 to both sides to get this y by itself. And then what I get is I get y is equal to -5/2x plus 15.5. And y is all by itself, which is what I have right there. That is my official equation that I want to go ahead and have. Okay? So that's kind of a lengthy problem. That's my favorite kind, or favorite type way to do it. Number 20 is y equals -4x minus 1. They want you to graph it. First of all, notice my little red m and red b. M is -4 in front of the x, and b is -1. B is where you begin. So first of all, before we do anything, go ahead and place a big dot at -1 on the y-axis. That's your y-intercept. That's where I begin. Okay. Then I need to graph my slope, which is -4. Remember that what you always want to do is put your slope as an over 1 if you need to. Okay. Always make it a fraction. So from this point right here, this -1, I now need to go down 4 and over 1. So down 1, 2, 3, 4 over 1 right here. Okay, and I keep going 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1, and keep going, and you should get pretty straight point. This one isn't perfect, but it's pretty straight, and that's your point. So you have a slope-intercept form, much. Number 24. Number 24, what we need to do is, it says write an equation in point-slope form for the line through the given point with the given slope. So it says point-slope form, so I went ahead in green and wrote down my point-slope form. And what I need to do is I need to label. So I've got x1, y1. I've got my m. I simply plug those things in. So I use y minus, plug in my y1, which is 2, equals my m, which is -1/4, times x minus my x1, which is 6. And I look around for things to clean up, and it looks like there's nothing else that I can clean up. So this is officially in point slope form. If you would have had like a x minus a negative 6, you would want to change that to x plus 6. And you can kind of see that in number 25 on the answer key that I show you as well. Number 26, you can do one of two ways. I think it's always easier when you need to graph something, because we do need to graph this, that you should try to get it in slope-intercept form, so get y by itself. So I'm not going to actually show you how to graph this, but I am going to show you how to get it in y-intercept form, which then makes it much, much easier to graph. So what I need to do is distribute this negative 1/4 to the x and the 5. So you get y plus 4 equals negative 1/4 x, and let's see, negative 1/4 times 5 will give you negative 1 1/4 or negative 1.25. And then to get this y by itself, I need to subtract 4 from both sides. And so I get y is equal to negative 1/4 x minus 5.25. Important to note that this is your slope, which is where you move, and this is your y-intercept, which is where you begin. And you're going to have to put your point just below 5, or just below negative 5, because it's negative 5.25, and then you're going to have to use your slope accordingly, and just be really careful. If you look at number 28, it says, what is an equation of the line? You need it in point slope form, because that's going to be the easiest one, because you can see a point, you can figure out a slope. First of all, I figure out my slope to be down 3 and over 5, which is negative 3 over 5. Then I figure out my point, or my x1, y1, to be, what is it, negative 1, comma 2. I'm picking the one on the left. So what I've got here is I've got my m, I've got my x1, I've got my y1. So now I'm going to plug stuff in. So I use y minus, my y1 is 2, equals my m, oops, don't need the parentheses, sorry, equals my m, which is negative 3/5 times x minus, careful with this, negative 1. Now I'm going to want to clean it up. So y minus 2 equals negative 3/5 is fine, times x plus 1, and there's nothing more to clean up. That's in point slope form. Remember that you could have gotten it down in slope intercept form if you want to use it for a graph or something. Simply by getting y by itself, I would need to distribute and then add 2 to both sides. Number 32 asks us to find the x-intercept and the y-intercept. First of all, x-intercept. What you actually do with the x-intercept, write your equation down, and you actually plug in 0 for x. Or, I'm sorry, for y. You plug in 0 for y. You actually plug it into the other variable. So if you're trying to find the x-intercept, you actually plug it in for y. If you're trying to find the y-intercept, you plug it in for x. So this is actually going to be plus 0, because 4 times 0 is 0. You don't even need the plus 0 anymore. So you're just going to have negative 6x equals 96. And then divide by negative 6 on both sides. And you're given x equals negative 16. Now, my y-intercept. Same process, same formula, only for my y-intercept, I'm plugging in 0 in for my x. So, what I need to do is, I've got negative 6 times 0 plus 4y equals 96. Again, this is going to give me 0. I don't need that 0 anymore, so I can just write 4y. Then I divide by 4 on both sides, and you get y equals 24. And those are your intercepts. Now, officially, just so you're aware, that answer will work. Now, officially, though, your actual x-intercept is actually negative 16 comma 0, because y is 0. And officially your y-intercept is actually going to be 0 comma 24, because again the other value is 0. Alright, x equals 4. For x equals 4, it says what is the graph of the equation? Now remember, find the axis. This is my x-axis, that's my y-axis. I find x equals 4, it's over 1, 2, 3, 4. Put a big dot there. And instead of drawing a horizontal line, you're going to draw a vertical line, because it is the vertical line, the one that crosses that axis at perpendicular 90-degree angle. So this, I'm going to label this as x equals 4. Okay, number 36. What you have to do is you're going to have to write this in standard form using integers. What that means is you want to get all the x's and y's on the left side, and you want to make sure all the numbers are not decimals. You want to make sure they are good, clean numbers like -2 or 5 or 7 or 102, but not decimals. So what we need to do first of all is I'm going to multiply everything by 10, and what that does is it will actually clear out those decimals. And so what we're going to get is 10 times y here is 10y. 10 times 0.6x is actually going to give you 6x. 10 times -0.1 is going to give you -1. So I cleared them of decimals. Now I need to move this 6x over here somehow. How I do that is I subtract 6x from both sides, and I get -6x plus 10y equals -1, and that is an equation in standard form using integers with no decimals. And I actually already explained number 38 and 39 in class. Number 40 and 41 we will talk about in class on Wednesday. So that's the end of the video. Good job.